Hello, welcome back to lecture. This time we're going to continue on with R5's chapter R, our review chapter, section 5, but this is going to be focused on solving absolute value equations or equations involving absolute values. So what exactly is my absolute value? It is basically this symbol. Here's what we're talking about. So I have the absolute value of -2. So what we're saying is, from here, what is the distance? Here's -1, here's -2. What is this distance between 0 and -2? Well, the distance is 2. If we're just not really concerned about the direction, and all I'm worried about is the magnitude, this thing is just 2. I'm just 2 units away from 0, okay? In addition, if I go this way, if I go 1, 2, this distance as I'm going here is 2. So the absolute value is kind of just giving me, I'm not really worried about the direction that I'm traveling, just give me that distance. And both of these are 2. So here is the formal definition so that I can get mathematically to do these two things. The absolute value of u, here's kind of to be able to remove this in terms of a variable. I want to do this, and then we'll kind of compare and see if it works here. It's just u if u is greater than or equal to 0, and it's negative u if u is less than 0. So here's the mathematical definitions. If I don't know what this thing is, it can be either positive or negative. I have to break these things out into two cases. But in terms of just numbers, the absolute value of -2, well, that's less than 0. -2 is less than 0, so I have to throw a negative in there. So negative times -2 just gives me the +2. And then here, it's greater than or equal to 0. 2 is positive, so I just say it's just whatever that number is. Okay, so that's the mathematic terms of it. Okay. So here's where we kind of work backwards when I'm solving equations. So I'm going to say I've got absolute value of x is equal to some number k, and this is positive. This is always positive, okay? Always positive, okay? If I have the absolute value of x equal to -2, I have no solution, okay? No solution. No absolute value is less than 0. Absolute values are always positive, okay? So here, I'm going to go, instead of putting this negative in front of here, I'm just actually going to put it here. Because let's say if this was 2, then x could be equal to -2 or x could be equal to 2. Either one of these things could be the negative number, okay? So if I stuck this in here, it would be 2, here's 2. So remember that all of this stuff could be either a negative or a positive, okay? So when we do absolute value equations, anytime I have the absolute value is equal to k, then I break out two solutions. U is equal to k, u is equal to -k. That's my fundamental picture here. This is a k. Okay. Absolute value is equal to 0 means that u is equal to 0. This is the only solution I have for this. Absolute value is equal to a negative number, is a negative number, okay? So here's -k, k is positive, positive. This has no solution. So this is like -3, -5. There's nothing with the absolute value that's going to give me that, okay? And if here I've got two absolute values, okay, then I'm going to do the very same thing here. U is equal to w, so this is the positive version. Or these could be like absolute value of 2 is equal to the absolute value of -2. So these were either equal or the negative, okay? That's basically what that's kind of giving you, those two types of situations. Okay. So let's see how we use these things to come up and solve absolute value equations. So here I want to look at this example. Absolute value of 2 times the absolute value of 3 minus 2t is equal to 6. Let's solve this. Okay, so I always want to have this thing come up to some fundamental thing that looks like this. The absolute value of an expression, so absolute value of an expression is equal to k. Okay, so I don't want this 2 times this. I want to go ahead and divide that out first. So I'm going to divide both sides by 2. Okay, now I get that. Now what does that mean? This means that the distance between another number, so before we just did one number and said what's the distance between 0 and that number. Here the distance between 3 and 2t, this is the distance or the difference of these two things, is equal to 3. Well, this could be equal to 3, or that expression could be equal to negative 3. That would make it 3. So what I want to do is break this out to this. It could be that number or this number. I've got two possibilities. If this is equal to 3, the absolute value of 3 is 3, I've got it. If this is equal to negative 3, once I solve, the absolute value of negative 3 is equal to 3, and that takes care of it. And these are the only two numbers where the absolute value is going to be equal to 3. So then I just simply solve, okay? So let's do, I'm going to leave this over here and then divide by a negative number. So I'm going to go negative 3. So minus 2t is equal to 0. Minus 2 to get rid of this, which says that t is equal to 0. Does that work? 3 minus 2 times 0 is 0, so this is just absolute value of 3 does equal to 3. And then this one, a very same thing, minus 3, so minus 2t could be equal to minus 6. How about t is equal to 3? Well, does 2 times the absolute value of 3 minus 2 times 3, does that equal to 6? 3 minus 6 is negative 3. Absolute value of negative 3 is 3. 2 times 3 is equal to 6, and that would work. Okay, so I've got actually two solutions, 0 and 3. That's my solution set. Okay. Let's do another one. Let's do 2 is equal to absolute value of 7w minus 3 plus 8. Okay. Again, I want this all by itself. So I'm going to go minus 8 from both sides. Okay. 2 minus 8, that gives me negative 6. Absolute value of 7w minus 3. Okay, and again, I've got the absolute value of something, the distance between here and here, but now look at this. Absolute value of any number is always greater than or equal to 0, and this is a negative number. So here we can stop and say no solution. I just have to recognize, hey, this can't be a negative number, okay? So solution set, the SS is equal to the null set. You can also write that as just that thing, the null set. But here, I think Alex would not want you to use that. He wants you to use something like that. Okay. So let's look at a couple more. How about the absolute value 2x minus 5 is equal to the absolute value of x plus 1? Well, I've got them here so that so we know this has got to be two versions. For these things to be equal, this has to be equal the same number, or these two could be negative. So absolute value of 2 is equal to the absolute value of 2. That works. And that works as well. Okay? Absolute value of 2 is equal to the absolute value of negative 2. So we know these two are the same. So I'm going to break these out, remove the absolute value. So that's possible. Linear equations are all powers of 1. X is on one side, numbers on the other. So I'm going to go minus x, and then plus 5 on both sides, which gives me x is equal to 6, or 2x, minus 5 is equal to the negative version. Okay, that would be the same thing if I take it and multiply the negative in here. So 2x minus 5 is equal to negative x minus 1. And I want to do plus x to get this over here. And then plus 5 to get rid of this one. And so x is equal to 4/3. Okay. And then we go through the check, and you can kind of go through that exercise and get those two as a solution set. Okay, let's see this one. How about absolute value of x minus 6 is equal to the absolute value of 6 minus x? Well, I'm going to break this out. They could be the same. So plus x on both sides. Okay. Plus 6 on both sides to get this over there. So x is equal to 6 would say 6 minus 6, 0. 6 minus 6, 0. The absolute value of 0 is equal to the absolute value of 0. Okay, so that works. How about if we break it out to the negative? 6 minus x is equal to negative x minus 6. Negative x plus 6. And we do the same thing. This is equals, it looks like make it like that. Plus x. And it says 6 is equal to 6. Whenever my variable disappears and I end up with something that looks like that a number is equal to a number, this basically says that this is identical. This is an identity. An identity is true for all x. It's just a different way of representing. And here all we've done is just factored out. These are the very same things, negative x plus 6. Okay, so here is all of r, or anything in that interval, any numbers. Okay. How about if I do this? I'm going to do this as a quick. How about if I end up with something like x plus 2 is equal to x plus 6? I'm going to do the very same thing. Minus x. This goes out, so 2 is equal to 6 is what I'm left with. This is a false statement, so the solution set is no real numbers. No x, when I add 2 to it, is going to be the same thing as a number that I add 6 to. Okay, so there's an empty no solution. No solution. This is the signature when I get rid of all my variables and I have a number, one number equal to another number when this can never be true. There's no number x that's going to be here. And here it says any number x Doesn't matter what x, it's going to be the very same thing. Okay. So that's the end of my slideshow. Let's not save, and if I go over here, that takes care of basically the fundamentals of doing absolute value equations. Get, go in there, get practicing, and we'll work on some other things in class. So see you next time.